the energy differences during a phase change using dimensional analysis. So the hint here is that it's a phase change, number one, and number two, that we have to use dimensional analysis to make this happen. So that's the hint in this particular problem. The other thing is it says it doesn't actually give you a temperature. Sometimes these problems will give you a temperature, but it'll be a singular temperature, like the ones that we worked on in class yesterday. One of the questions was, what an ice cube will freeze at 0 degrees Celsius or something like that. If I only give you one temperature, it's going to be a problem where you're asked to do a phase change. So in this case, I know that with my phase change calculations, I'm going to go mass to mole to energy. Okay. So I'm going to take the 0.88 grams of, it says acetone, which is fingernail polish remover, which is C3H6O, put it over 1. I'm going to go mass to mole to energy. Now, in this problem, I see that I have 3 carbons. I have 6 hydrogens. And I have 1 oxygen. So I get a molar mass here of 58.09 grams in 1 mole of C3H6O. So now I'm going to take that value and put that in my mass to mole step. So I'm going to put the mass, the 58.09 grams of C3H6O on the bottom, and 1 mole of C3H6O on the top. So now I'm going to go mass to mole to energy. So the key here is that it says that it evaporates or vaporizes. Okay, so if it vaporizes, that means that I have to use the delta H that associates with vaporization. So in this problem, I'm going to be using the delta H of vaporization of acetone, which is 30.2 kilojoules per mole. So I'm going to take that 30.2 kilojoules in 1 mole and put it here because that's my delta H of vaporization. So when I plug this into my calculator, I'm going to take the 0.88 divided by the 58.09 times the 30.2, and I get the amount of energy required here to be something like 0.45749. So, but because I need to have 2 sig figs, it's like 0.46 kilojoules of energy. Now, something to make point of here is that if we are adding heat, like to make something evaporate or vaporize, it's endothermic. So delta H is negative. And if heat is released, it's exothermic. So delta H is positive. So because we were evaporating, we would have to assume that we are adding heat. So that means that the sign here is going to be positive, which means our answer is going to be positive. Any questions about this? All right.